Hey guys, I'm gonna once again go over your math minute that's in the 5th grade alternative learning packet. So you were supposed to be working on these this week. Some of you who I talked with said that you already finished, so that's awesome. This is an opportunity to go over it. So if you've been checking out my YouTube channel, you saw that I went over the difference between prime and composite numbers and even and odd numbers. So I'm not really going to spend a whole lot of time going over that. If you don't remember the differences between prime and composite numbers and even and odd numbers, I recommend you check out that video on my YouTube channel. So you're allowed to use a calculator for this. So I'm going to get the calculator tool. There it is. Okay, and hopefully it comes up. There it goes. Computer's slow. So you can use a calculator to determine what a number is divisible by. And let's see here. Hello. There we go. My gosh. Move this over here. Okay, so it says circle the composite numbers below. Alright, so I'm going to go ahead and circle the even numbers because the even numbers are divisible by 2. So I know that 12 is composite because it's divisible by 1 and 12, and it also has to be divisible by 2 because it's an even number. And it is. 12 divided by 2 is 6. 64. That also has to be composite because it's divisible by 1 and 64, but it's also divisible by 2. 64 divided by 2 is 32. Okay, so those two numbers are definitely composite. So now we got to look at the other ones. 17, 43, 81, and 97. Alright, and unfortunately, to switch to using the calculator and back to the pen, I have to erase the pen. So, sorry about that. Okay, there's the calculator. So, let's start with 17. In order to figure out if 17 is composite, we are going to see what it's also divisible by. So I can use the calculator and just kind of divide by everything. It would just take me a while. There's some numbers I can skip. There's some factors that I know are just not going to work. For example, I know 17 is not divisible by 2 because it's an odd number. Okay, so 17 divided by 3. Now, some of you know the divisibility rules, so you know the trick to see if a number is divisible by 3. You add up the digits. So 1 plus 7. 1 plus 7 is 8, and it is not divisible by 3. So that's how you know that 17 is not divisible by 3. You add up the digits, and if the sum of the digits is divisible by 3, then the number is divisible by 3. For example, 12, we know that that's divisible by 3 because 12 divided by 3 is 4. So add up the digits. 1 plus 2 is 3. 3 is divisible by 3. It works. So those are two ways that you can check to see if a number is two ways that you can check without dividing with the calculator. Is it even? If it's not even, then it's not divisible by 2. Do the digits add up to a number that's divisible by 3? If they do, then you know that it's divisible by 3. But if you don't, then you know that it's not divisible by 3. Okay, 17 is not going to be divisible by 4 because it wasn't divisible by 2. All right, 17 divided by 5. we know it's not going to work because if a number is divisible by 5, then it has a 0 or a 5 in the ones place. Didn't work. 17 divided by 6. It's not divisible by 6 because it wasn't divisible by 2. 17 divided by 7. We can actually try that with the calculator. Does not work. 17 is not divisible by 7. 17 divided by 8. It's not divisible because 17 isn't divisible by 2. So it's not going to be divisible by any multiples of 2, like 2, 4, 6, or 8. is 17 divisible by 9? No, because it wasn't divisible by 3. Is 17 divisible by 10? No, because the multiples of 10 are 10, 20, 30, 40, and so on. Finally, is 17 divisible by 11? Well, if you know the divisibility rules of 11, you would know that when the digits are repeated, that indicates that it's divisible by 11. So like 77 would be divisible by 11. 17 is not divisible by 11. There you go. That means 17 is prime. All right, let's go to 43. Okay, so I'm not going to divide by 2 because it's odd. Let's see if it's divisible by 3. Now 4 plus 3 is 7, and that's not divisible by 3. So, yep, didn't work. We'll skip 4 and we'll skip 5 because 43 is not divisible by either. It's not divisible by 6. We can try 7. Not divisible by 7. Not going to be divisible by 8 or 9. It's not going to be divisible by 10. And it's not going to be divisible by 11. So 43 is also prime. Alright, we'll skip to 81. Okay. 81 is not divisible by 2 because it's an odd number. Let's look at the digits in 81. There's an 8 and a 1. 8 plus 1 is 9. Now 9 is divisible by 3. That means that 81 should be divisible by 3. Let's check. Yep, it's divisible by 3. That means that 81 has at least 4 factors. 1 and 81 and 3 and 27. That makes 81 composite. Okay, finally, 97. Okay, so 97 is not divisible by 2 because it's an odd number. Is 97 divisible by 3? Well, the digits 9 and 7 add up to 16. That is not divisible by 3, so it shouldn't work. 97 will not be divisible by any of the multiples of 2. 2, 4, 6, or 8. We can skip those. 97 will not be divisible by 5 because there's a 7 in the ones place. Is 97 divisible by 7? Whoa. Try that again. Nope, doesn't work. 97 will not be divisible by 9 because it wasn't divisible by 3. 97 is not divisible by 10, and it's also not divisible by 11. 99 is divisible by 11. That makes it a prime number. So, composite, 12, 64, and 81. Okay, so I do want to comment on one thing. There is one even number that's prime. Earlier I said that even numbers are composite because they're all divisible by 2. The number that is both prime and odd is 2. Because 2 only has 2 factors. 1 and itself. Yes, 2 is divisible by 2. It just so happens to be itself. Again, if you go to the Prime and Composite YouTube video that I made, then you will get to review all that. Okay, so it says circle the prime numbers below. Oh, it's the same numbers. That makes it easy. This one was prime. Oop. This one was prime. This one was prime. And this one was prime. Odd numbers. Okay, so in order to figure out if they're odd, we check to see if they're divisible by 2. Okay, you can use a calculator to do that. 12. Nope. 12 is divisible by 2, so it's even. 17 is not divisible by 2, so it's odd. 43, it's not divisible by 2, so it's odd. 64 is divisible by 2, which makes it even. 81, not divisible by 2, that makes it odd. And then 97 is not divisible by 2, so that also makes it odd. So the odd numbers are here. Now, you probably remember in 1st and 2nd grade, the trick to help you remember, in the ones place, look for a 0, 2, 4, 6, or an 8. That indicates that the number is even. So that's the multiples of 2 have a 0, 2, 4, 6, or an 8 in the ones place. Okay. So let's go to the true and false. It says if you add one even number to another even number, the answer is also even. Okay, so there's a couple ways to prove this. First of all, I'm gonna get rid of this just so I can show you. You can use an example. So we could do like 8 plus 8. 8 is an even number, it's divisible by 2. So 8 plus 8 is 16. 16 is also an even number because it's divisible by 2. The other way to think about it is to think about the meaning of an even number. Even numbers, because they are divisible by 2. So 8, for example, they always have a pair. It's like an array where one side is 2 and the other side is another number. There's always a pair. So this one is 8 plus 12. If you were to put these two together, combine them, then this would become one long array. It would be 10 by 2. By 2. Do you see how every number, or each square, has a friend? They're paired together. 2 times 10 is 20. 20 is also even. Okay, so that's true. If you just think about it, it makes sense. An even number means it's divisible by 2. If you're adding it to another even number that's also divisible by 2, think about it. The answer could be divided into 2 equal parts. Let's go to B. If you add an odd number to another odd number, the answer is also odd. Well, again, let's start with an example. 7 plus 5. 7 is odd and 5 is odd. When you add them together, you end up with 12. Hey, 12 is even because it's divisible by 2. So our example already proves this to be false. Let's think about odd and even from arrays, the perspective of an array. Let's do 5 plus 7. So there's 5. We know it's odd because of this square right here. It doesn't have a pair, the odd man out, so to speak. If we were to add 5 plus 7, they kind of fit together like Tetris. They fit together to make an array that is divisible by 2. They make this array. Six by 2. That is divisible by 2. It's an even number. All right. So examples can help you, and also building arrays can help you. Let's look at C. If you add an even to an odd number, the answer will be even. So again, think about an example. 6 plus 7, that's 13. 6 is even, 7 is odd. 13, that's not divisible by 2. It's an odd number. That means that an even number plus an odd number makes another odd number. So our example proves that to be false. Think about it from the perspective of an array. If we were to do 6 plus 7, our array would have an odd man out. Makes an odd number. Okay? True, false, and false. All right, Tuesday. Order these fractions from least to greatest. All right, this kind of goes back to some of the review we did last week in our math minutes. We'll start with 5. 1 and 2/10, 3/10, 1/2, and 1 1/4. All right, so it helps to think about a number line. And we'll go from 0 to 1 whole, and we'll go up to 2. There's no numbers that are 2 or greater. Okay, so in between 0 and 1, we'll put 1/2. And in between 1 and 2, we'll put 1 1/2. Okay, so these two numbers here, 1 and 2/10, and 1 1/4, are both greater than a whole. These ones, 3/10 and 1/2, are less than a whole. Okay, so it helps us to know the value of 1/2. If you think about 1/2 of $1, that's equivalent to 50 cents. 5/10. So 1/2 is the same as 5/10. We can now compare 5/10 to 3/10. 5/10 is greater than 3/10. So that puts 3/10 over here. Placed, placed. Okay? So now let's look at 1 and 2/10 and 1 1/4. Okay. So 1 and 2/10 we'll leave as a decimal. Let's change 1 1/4 to be a decimal as well. You might know that 1/4 of $1 is the same as 25 cents. That makes 1 1/4 equivalent to 1 25/100. So now we can compare 1 2/10 to 1 25/100. And it helps to go one place value at a time. Start with the whole. 1 and 1 are the same. So now let's go to the 10th place. 2/10 is the same as 2/10. Still the same. Let's go to the next place value. 0/100 versus 5/100. Well, 5/100 is more than 0/100, which means that 1 1/4 is greater. One 1/4 is greater than 1 2/10. Okay. So now let's go to 6. We've got 3/10, 9/10, 2/3, and 1/5. All of them are less than a whole. So my number line can go from 0 to 1. I'll put 1/2 in the center, which is equivalent to 5/10. Okay, so 3/10 and 9/10. Let's put them on the number line. 3/10 is going to be, let's see, this is 0 to 5/10, so we can say 1/10, 2/10, 3/10, 4/10. So 3/10 would be about here. So then I can keep counting. Let's see, 6/10, 7/10, 8/10, 9/10. So 9/10 would be about here. 9/10 is close to 1 whole. 3/10 is close to 5/10. All right, so now let's go to 2/3. Okay, so 2/3, we can divide the numerator, divide it by the denominator. I'm going to give myself some space. So 2 becomes the dividend, 3 becomes the divisor. Okay. Can you do 2 divided by 3? No. Now I'm at multiply. 0 times 3 is 0. Subtract. And I have a 2. Check. 2 is less than the divisor, so now I can bring down. So now I've got 20 divided by 3. 20 divided by 3, 6. 6 times 3 is 18. Subtract, and I get 2. Check. 2 is less than the divisor. What do we notice? It'll continue. That means that 2/3 is the same as 6/10 with the 6 repeating. 5/10 is greater than 6/10 but less than 9/10. So because the 6 will repeat, it's actually closer to 7/10. I put it here. Okay, so now we need to figure out 1/5. Okay, so one easy way to figure out the decimal equivalent of 1/5 is to make an equivalent fraction. So let's skip count to make our equivalent fraction. 5, 10, 15, 1, 2, 3. 2/10. I can write that easily as a decimal. 2/10. So 1/5 is equivalent to 2/10, which goes here. So the order is 1/5, then 3/10, then 2/3, then 9/10. All right. Okay, rounding. In order to round, I'm going to zoom in. Oh, went the wrong direction. Okay, there we go. says round 451 and 286 thousandths to the nearest hundredth. So in order to do that, we need to highlight the digit in the hundredth place, which is 8 hundredths. Now we're going to look to the right at the thousandths place. 6 thousandths makes the 8 round up. So this number becomes 451 and 29 hundredths. All right, so let's go to the next one. This one here says round 29 and 74 hundredths to the nearest tenth, and I'm going to do it on a number line. So they're asking us to round to the nearest tenths. So I see 7 tenths. I'm trying to decide if 29 and 74 hundredths rounds to 29 and 7 tenths, or rounds up to 29 and 8 tenths. Okay? So in between 29 and 7 tenths and 29 and 8 tenths are 10 hundredths. Okay? So let's see. 29 and, oops. Let's give myself a little bit more space. 29 and 71 hundredths, 29 and 72 hundredths, 29 and 73 hundredths, 29 and 74 hundredths, 29 and 75 hundredths. And I will go ahead and write these out for you. Okay, so I can keep going up. 29 and 76 hundredths, 29 and 77 hundredths, 29 and 78 hundredths, 29 and 79 hundredths, and then finally 29 and 80 hundredths. Okay. So, again, we're trying to decide, is it closer to 29 and 7 tenths or 29 and 8 tenths? So let's find 29 and 74 hundredths. It's right here. On the number line, that is closer to 29 and 7 tenths. So, if you were to round 29 and 74 hundredths, it rounds to 29 and 7 tenths. Okay, 9. Which goes in the blank to make the statement true? We've got the number 2 and 301 thousandths. Okay. So, let's look at choice A. Actually, let's put these all in order. Like, let's put these all on top of each other. It helps us compare them. I've got 2 and there we go. The decimal point's giving me a hard time here. All right, 2 and 301 thousandths. The next one is 23 and 1 tenth, so I can add zeros in the hundredths and thousandths place there. All right, B says 2 and 3,010 ten thousandths. So I'm going to put the 3 in the tenths place, 0 in the hundredths place, 1 in the thousandths place, and 0 in the 10 thousandths place. Oops. It's supposed to be a 0. C, 2 and 300 10 thousandths. D, 2 and 13 hundredths, and I'll put a 0 in the thousandths place. So now I can compare them going by place value. All right, let's start in the tens place here. This number 23 is greater than the other ones because this one, that's 0 tens, 0 tens, 0 tens, 0 tens. So that makes this number, this number, 23 and 1/10, that's not going to work. It's definitely not greater than 2 and 301 thousandths. We'll cross it out. Let's go to the next place value, the ones place. Can you compare them based on the ones place? No. I've got 2, 2, 2, and 2. So let's now go to the 10th place. Okay. Got 3 tenths, 3 tenths, 3 tenths, and 1/10. 2 and 13 hundredths here at the bottom. That one is the least. This one is the least. That means that it's less than 2 and 301 thousandths. Okay? All right, so I eliminated that one. Let's now go to the hundredths place. All right, I see 2 and 310 thousandths is greater than the other two. This one's greater because 1/100th is greater than 0/100ths, so we can eliminate that one as well. So now we only have 2 left, so let's go to the thousandths place. 1,000th and 1,000th. They're the same. Let's go to the 10,000ths place. 0 10,000ths and 0 10,000ths. They're just the same number. Okay? This number and this number are the same. You can add as many zeros and it doesn't change the value. So 2 and 301 thousandths is greater than 2 and 13 hundredths. But the other ones, it's less. Okay, order of operations. So, we went over order of operations last week when we were doing our math minutes. We remember PEMDAS, parentheses, and exponents. Multiplication, which is the same as division, so we go from left to right. And addition and subtraction, which they're the same thing. We just go from left to right. Okay, so for number 10, it says 7 times the quantity of 84 plus 19. The first thing I see is what's in parentheses, so I'm going to highlight that. 84 plus 19 is 103. I can cross out parentheses now because there's no more. I don't need to bring down the parentheses because they have the multiplication symbol there. They could have written it like this, and if they had, I would have needed to bring down the parentheses symbol because that would indicate 7 times the quantity. There's more than one way to write something. Okay, so now we have 7 times 103. I don't see exponents. I see one multiplication one thing to simplify with multiplication. 7 times 103. Okay, and that gets us 721. Simplifies to 721. Okay. We'll do the same thing now with number 11. Okay, so number 11 says 48 minus 7 times 2 divided by 7. Okay, I don't see parentheses, so I can cross that out. And I don't see exponents, so I can cross that out. I do see multiplication, and I do see division. So I'm going to do 7 times 2 first, because remember I go from left to right. And I see 7 times 2 before I see 2 divided by 7. 7 times 2 simplifies to 14. So now I bring down the rest of the problem. I can't cross out multiplication or division because I now see 14 divided by 7. So that's what I'm going to simplify next. And that simplifies to 2. So now I can cross out multiplication and division. What I'm left with is addition and subtraction. And that simplifies to 46.